The quantitative portion of the GRE follows a normal distribution with a mean of 150 and standard deviation of 8.8. What proportion of the quantitative GRE scores can be expected to be over 160? So we'll start off by drawing a picture. We have our normal distribution there with a mean of 150. And we want to focus on the area over 160. So we're talking about proportion, so the same thing as area or probability, so we're going to use normal CDF. So we're looking for essentially the probability that X is greater than 160, so we're going to use normal CDF, and our lower bound is 160, upper bound is 1E99, our mean is 150, and our standard deviation there is 8.8. So we're going to type that in our calculator. So we're going to do second bars to 160, 1E99, 150, 8.8. So we're looking at 0.1279, so roughly about 13%. So the next part, we want to know what proportion of the quantitative GRE scores can be expected to be under 160. We can use our complement rule here since we already have that up. So we're looking at under 160. So we can do 1 minus our answer that's up there. There's our answer. So let's assume that we don't already have that. So we would do normal CDF negative 1E99, 160, 150, 8.8. So if we do that here, so do normal CDF negative 1E, so again the E is second comma, 99, 160, 150, 8.8. Let's see if we get that answer there. So 0.8721. Our next part. What proportion of the quantitative GRE scores can be expected to be between 155 and 160? So I'm drawing a rough picture here. So we have our mean of 150. So we're looking between 155 and 160. So our area here. And the probability that X is between 155 and 160. So we're going to use normal CDF. And our lower bound is 155, our upper bound is 160, our mean is 150, and our standard deviation there is 8.8. So mu is 150 and sigma is 8.8. So we can type that in, we get so 155, 160, 150, 8.8. So we get 0.1571, so roughly about 16% there. The next part, we want to know what's the probability that a randomly selected student will score over 145 points. So we're looking for probability. We're looking for proportion, area under the curve. All those things, we're still going to use normal CDF to calculate that. So again, let's get here. We're looking at over 145. So our mean 150, 145. So we're looking at this area here. So we want the probability that x is greater than 145. So we're going to use normal CDF. And our lower bound is 145. Upper bound is 1E99. Mu is 150. And sigma is 8.8. I'm going to type that in. So second vars 2, 145, comma, 1E99, comma, 150, comma, 8.8. And we get roughly 0.7150 there. That's our answer. So the next part, we want to know what's the probability that a randomly selected student will score less than 150 points. So let's draw this out. So our mean there is 150. We want to know less than 150 points. 150 points. We don't have to do any work there, right? We know that it's symmetric, and we know that there's 50% on each side. So this is equal to 0.5. Okay. So F, we want to know what is the percentile rank of a student who earns a quantitative GRE score of 142. So when we're asked to find the percentile rank, that's the same thing as finding the area under the curve, the probability, the proportion. So we're going to use normal CDF. So we have to think about what this means. So right in the middle we have our 150. And then 142 over here somewhere. So percentile rank, that tells us what percent had that score or less. So we're looking at the area underneath that value. So the area to the left of that value, not underneath. The area to the left of that value. So we're looking at the probability that x is less than or equal to 142. So we're going to do normal CDF. So anytime you have percentile rank, you're going to do less than or equal to that value. Negative 1E99, comma, 142, comma, 150, comma, 8.8 here. So let's see what we got. Second vars 2, negative 1 E99, comma 142, comma 150, comma 8.8, close our parenthesis, and we get roughly 0.1817. So if we round that to the nearest percent, we'd look at 18%. So we're looking at the 18th percentile. There. So now we're looking at, as that historically, the Department of History at NYU has admitted students whose mean quantitative GRE score is in the 61st percentile. And we want to know what is the mean GRE score of the students they admit. So this time, we know we're looking at the 61st percentile. We want to know the value that matches that. So we know the area under the curve to the left. So this area is 0.61. So x is equal to the inverse norm of the area to the left, which is 0.61, comma the mean, which is 150, comma standard deviation, which is 8.8. Let's do that and calculate that. So second bars 3, so we're asking to actually find the score. So when we want to know the score, we're going to use inverse norm. Area to the left, which is 0.61, comma the mean, which is 150, comma standard deviation 8.8. Close our parenthesis, and we're going to round this to the nearest whole number, so 152. That's our score of the students that they admit. So the next part, we want to determine the 80th percentile of the quantitative GRE scores. So very similar to the last one. So we're going to do inverse norm and 0.8, comma 150, comma 8.8. So I'm going to do second entry to pull up what I just typed in, go over that 0.61 and change it to 0.80 and press enter. So this is approximately 157. There's our 80th percentile. So next question, we want to determine the quantitative GRE scores that make up the middle 95% of all scores. Let's draw on a picture here. So they're telling us this middle chunk here is 0.95. So we have 5% left over, so 5 divided by 2 is 2.5. So let's convert that to a decimal, so that's a percent. So we have 0.025 in each segment here. Right? Since we have 0.05, and then if we divide that by 2, right? So we have x1 that we're looking for, and x2 that we're looking for. So x1 is going to be inverse norm of 0.025, comma 150, comma 8.8. Let's see what that is. So second bars 3, 0.025, comma 150, comma 8.8. So that's roughly 133. And then x2, we want to add up these two values. That's going to be my area to the left. So we're going to do inverse norm of 0.025 plus 0.95, comma 150, comma 8.8, and see what we get there. So second bars 3, 0.025 plus 0.95 plus, oops, sorry, not plus, comma 150, comma 8.8. Close parenthesis, enter, and we get 167. So our two scores that make up the middle 95%, so all the things that are between 133 and 167. So scores between 133 and 167 make up the middle 95% there. So now we're going to compare the results in the previous part to the empirical rule. So empirical rule says 95 is 2 standard deviations away. So I'm going to write down our values here. We used, what was it, 132 and 167. So still have those two values in the calculator. So I'm going to go ahead and write out all the decimals from the calculator so we don't lose those values here. So empirical rule says 2 standard deviations.